Hi, this video is a lecture taken from my online course about data engineering on Microsoft Azure, and I hope it helps you learn more about data engineering. In this lecture, we are going to learn how you can use create external tables as select in serverless SQL pool. In general, you can use CTAs to create an external table or to export the result of a SQL statement in parallel to either Hadoop, Azure Storage Blob, or Azure Data Lake Storage. Because we are using serverless SQL pool, what we are going to do, we will use CTAs to create an external table and export the query result to Azure Storage. Here you can see the syntax of this operation. It is quite simple. We specify create external table, the table name, the location, meaning the path to a folder, as you can see here. This has to be a folder because in case where the select statement is running in parallel, then you will have multiple files that will be produced out of this select statement, and those files will be stored inside this folder here. This is the data source, meaning how to authenticate against the storage location. And here you have to define the file format for the file to be produced. So let's see how you can do that. Go ahead and use the following notebook to open row set CTAs notebook. If you can remember from one of the last lecture, you can use the open row set function to query data that are directly inside a storage account. For example, over here we like to query a file that is located in our storage account. The container name is data, the folder name is intro dataset, and the file name is Parquet. Because this is a Parquet format, we don't have to specify any columns. We can just execute this, select a connection, make sure you choose a user that also has access to the storage account, or you can use a shared access signature key. So let me connect over here, and you can see this then return exactly one record as we specified over there. We can also do the same thing with CSV files. We'll be querying the file web-sales.csv that contains sales information. And for that, we like to have the item ID, the billing address, and the order number. We can execute this. And as you can see, it then returns only one record because we set top one. Now let's say we want to join this result with this result, meaning we would like to know to which address we are supposed to send the bills of the order. To be able to do that, we'll then have to join this with this. So we'll have to join the bill address SK from the web sales file with the address ID from the Parquet file. And by doing that, we can then create a file that contains information coming from both files. Let's see how to do that. Now, first make sure that you are using the IntroDB, that we created earlier. Let me execute this. Make sure I'm using the IntroDB, and here I'm just checking if all my file format are still existing also as my data sources, because we are going to need them. Let me clear the result over here. Even collapse this, I don't need that. So down here, there's one thing we can do at first. We can use a common table expression. A common table expression is a way to give a select statement a name. If you want to learn more about common table expression, you can use the following, the link above, and then you will go to the documentation. Simply explain with a common table expression, you specify the with keyword, you give it a name, and then you specify the query that you would like to address with the following name. Meaning, after this statement, we can use customer addresses to reference the result of this. And we can also add multiple common table expression. So I can define one over here. After that, you specified comma, and then you define a second one. And this time what I'm doing, I'm just defining two CTAs, like for the Parquet file and for the sales files. One we then have to do at the end is to go down here and then select all the rows or all the columns from the web sales files. What I'm doing, I will take the item ID over here and just give it another name. This is nothing new. This is how SQL works. You can give a column an alias. I'll do the same with the order number. I'll just call it the order number. And from the customer addresses, I will select all the columns like this. Now you can then say from customer addresses, inner join web sales. Remember, this is web sales, a common table expression, and customer addresses is also a common table expression. Now what I'm doing, I will join both common table expression based on the billing address ID and the address ID from the Parquet file. And when we do that, we can then execute this. And when the query is successfully executed, you can then see down here that we scanned almost 215 megabyte and we moved only 65 megabyte. Here you can see we now have item ID, order number, the address ID. From here, what you can see over here, these are all the columns from the Parquet file. And what you are seeing over here are the columns from the web sales file. Now we have the result, and what we want to do is to create an external table with this result. And for that, you can then go down here, use the exact syntax that we saw earlier in the documentation. Here, create external table, give it a table name, specify a location. The location has to be a folder inside the data source, and then define the format of the data that has to be produced. So what I'm doing here, I will create an external table with the name billing addresses, with the location should be intro dataset / billing addresses like this. The data source is the intro data. The file format is the Parquet file format. If you go over here, databases, you can see external data sources. We have an intro data source that we defined earlier in the previous lecture. And we also have a Parquet file format that we also defined in the previous lecture. And we are going to use those objects directly here. After we do that, we can define either a select statement or we can use a common table expression. Again, check here. This is the syntax. After defining location, data source, and file format, you can use a select statement or you can use a common table expression. In our case, because we have a slightly complex query, it is better to use a common table expression. Now you can specify the common table expression that we defined earlier. We just get the common table expression and insert it down here. And by doing that, the result of the common table expression will then be exported into this location, and we can reference the data as a table using the following name. So let me execute that. Now you can see we scanned 214 megabyte, we move 0 megabyte, but we write 5 megabytes, meaning the table contains almost 5 megabytes of data. If you then expand over here, open the tables, you can see we have a new table, billing addresses. And this is this table over here. What you can then do is to, let me insert some code above. You can do something like select star from billing addresses. Let's say top 10, for example. Execute that. Now you can see we have a table with item ID, order number, and all the other columns coming from the address file. We can also count the number of records that are available in this file, like count this and execute. 719,000 records are available in the table. Let's take a look into our storage account. You can go over here. Let's refresh this. Intro dataset. Now you have a folder, billing addresses, and inside that folder you will see a Parquet file. This is the file that the table is referencing. So the table is referencing the following folder, and it is using all the Parquet files that are available in the folder to generate the data. Remember, this is an external table, which means if you delete the folder, the table will still be existent, but there will be no data. So I can do the following. If I go over here and just delete this, let me refresh over here. You see, I still have a table. But if I now try to query the table, I will get an error because we deleted the data. So what I have to do, I can just do drop external table, billing addresses. I drop the table and I can recreate it again. Let me refresh this. There we go, we have our table again. Now you can also write some complex queries now because you can use this as normal SQL table and you don't have to only write simple select statement. For example, let's write the following query. We can do a select. We like to have the item ID, the city, and count the number of items per city. We give it a name like item count, for example, from the billing addresses, where let's say the city is not null, and we like to group that by the item ID and the city and order it by the item count descending. Let me execute that. And now you can see the item with the ID 11395 was delivered in the city Antioch 6 times. So now that you have an external table, you can write normal SQL. And this is how we can create an external table as the result of a select statement. See you in the next lecture. If you enjoyed this video, I think you will also like the entire course. The course covers multiple Azure services that you can use to perform data engineering. For example, you will learn how to build a data pipeline using Azure Data Factory, or how to use Azure Key Vault to secure access to your data. Also, with Azure Synapse Analytics, you will learn how to build a modern data warehouse in the cloud, or how to run Apache Spark code using Azure Synapse Analytics. And it covers other topics such as Azure SQL databases and much more. So check it out using the link below. Thank you.